What's up, everyone? So today we'll have proof of this um, gamma formula by the Gaussian representation. So first of all, we all know that gamma function equals the integral from 0 to infinity of t to the s minus 1 e to the minus t dt. There's another formula for this e to the minus t, which is the limit as n approach to infinity of 1 minus t over n to the power of n. So we can change the gamma function formula into this shape. I'm sorry. The limit as an approach to infinity of the integral from 0 to n of t to the s minus 1, 1 minus t n to by n to the power of n dt. So let's take this integral, this side. So how can one solve this? We can try integration by parts. Let's say that this equals v and this equals u. So equals u and v. No, this equals dv. So let's integrate that. We'll get as t by s multiplied by 1 minus t by 2 to the power of 2 from 0 to n minus v du, which is t by s n 1 minus t by n to the power of n minus 1 and by the chain rule minus 1 by n dt. So this will all go will be equals to 0. So the uh, the gamma function will equals to um, sorry by s um, n s multiplied by n integral from 0 to n t to the power of s multiplied by 1 minus t by n to the power of 1, n minus 1 dt. So let's do it again. The integration by parts. N s multiplied by n dv u equals to t s plus 1 s plus 1 multiply 1 by 1 minus t by n minus 1 from 0 to n. Of course, will equals to 0 minus integral from 0 to n t s plus 1 s plus 1 n minus 1 1 minus t by n minus 2 minus 1 by n dt. So will equals to n s multiplied by n and multiplied by also n minus 1 s plus 1 and also n, the integral from 0 to n t s plus 1 1 minus t by n minus 2 dt. So let's do the integration by parts. So another one. So n s multiplied by n minus 1 s plus 1 n t s plus 2 s plus 2 1 minus t by n minus 2 0 to n will also equals to 0 and minus the integral from 0 to n t s plus 2 s plus 2 n minus 2 1 minus t by n minus 3 minus 1 by n dt. So this will equals n s plus s multiplied by minus 1, s plus 1, n, n minus 2, s plus 2, and the integral from 0 to n t s plus 2, 1 minus t by n minus 3 dt. So I think that's enough. We get this, see, we can make this into a sequence. We can realize that let's make this equals 1 so we can integrate it easy. But how? Let's say this will be integrate into n times. So this will equals n minus n, which equals to 0, so this will equals to 1. So n s multiplied by n minus 1, s plus 1, n minus 2, s plus 2, and so to 1. Um, let's put these parentheses into and multiply by n to the integral from 0 to n t. So if this goes to n times, so how will be this? It will be t to the power of s plus n minus 1 minus 1 because it's always less than by 1 for this. So it's easy dt. And this always stays the same, this and this. So this will be s plus n minus 1 equals n s multiplied by n minus 1, s plus 1, n multiplied by n minus 2, s plus 2, n so to 1, s plus n minus 1, n t s plus n s plus n 0 to n will equals to n s multiplied by n minus 1, s plus 1, n minus 2, s plus 2, n multiplied by 1, s plus n minus 1, n multiplied by n s plus n s plus n. So we got this not final answer. No, sorry. We can realize up there, this is the factorial formula sequence. So we can change it into n factorial. We can realize that it's also always n multiplied by n. So it is easily n to the power of n multiplied by n s plus n, and we can see down here s multiplied by s plus 1, s plus 2, s plus n minus 1. How can we write it down? It's always multiple, so we can change it into a product and let's say k equals to the n 1 s plus k, and we started by only s, so k equals to 0. So let's simplify. This will equals n factorial n to the power of s, the product as k equals to 0 to n 1 s plus k. So if k equals 0, this whole thing will be 1 by s. So we can change it to n and take for s and s. The product as k equals to 1 to the n 1 s plus k. The factorial is 1 to the power of 2 to multiplied by 2 to multiplied by 3 multiplied by 4 and to the n. This is n factorial. So this product is started at 1, then 2. So if we put k, for example, this will equals 1 multiplied by 2 multiplied by 3, 2, k. So it is simply k factorial. So n factorial, we can put it here. We can put it here, and this will equals n to the power of s, and by s, the product as k equals 1 to the power 2n k s plus k, which is the limit as n approaches infinity, n to the power of s by s, product as k equals 1 to the n k s plus k, which is the gamma function. And that's it.